Now, so welcome everyone to our IVI weekly coffee and talk. I'll hand over to Dr. Edgar Galvan, who is based here in Maynooth University and who works with the business school and also is collaborating with ourselves in the IVI as well. So I'll hand over to you, Edgar.
Thanks a lot, Grace. This is probably the first time that I'm being recorded. So I might be a bit shy, hopefully not. So thanks a lot for the invitation to you guys. And so I have been working on artificial intelligence for a good number of years, probably for 20 years or so. And recently I started working with people from business, with Marcus, Sore, and also have been in contact a lot with Paul and Grace, so it has been great. And I want to prepare a presentation that will make sense to all of us. And so I decided to go for this one, which is AI and digital transformation, and how we can bridge a gap between these two areas. So once again, thanks a lot to the IVI Institute for this coffee chat. So hopefully it will make sense what I will be talking about, and hopefully you will find this interesting. So as Grace was mentioning, I am in the Department of Computer Science. I am leading this research group, and we call it the Naturally Inspired Computation Group. And so I am leading this machine learning artificial intelligence part, and my good collaborator Peter Mooney is in charge of geocomputing. And we have a good number of PhD students. We have also a senior staff member with us. And what we do in the group is really to try to take inspiration from nature to try to solve some very interesting problems. And we call this area evolutionary algorithms. And we have been applying these techniques into a good number of real world problems, from software engineering, board games, video games. Also, we are very interested in the use of EAs, of evolutionary algorithms, in the Ferrari of machine learning, which is these deep neural networks. And we also use a good number of combinatorial optimization problems to do our research. So these are the latest papers that we have been publishing in the group. All of these are submitted to the journals in the area of computer science. IEEE transactions are very reputable journals, the same one for applies of computing. And so the takeaway message here is that we are doing lots of very interesting things around evolutionary algorithms, artificial intelligence, using different kind of problems. For instance, in this one, number one, we are using data from real world, and the idea is to classify that data in a meaningful way. In this one, what we are doing is try to find very good networks so that they can perform extremely well. So we did a literature review in the area. The area is just massive these days. And finally, we have been using something similar to what we did in number one, semantics, applied to games in a new algorithm that is called Monte Carlo tree search. So I always use these kind of slides for you guys to know what we are doing, and hopefully to engage in some form of collaboration in the very near future. So this very short presentation is inspired by lots of cool research. Mainly, I'm focusing on discussing these 4 papers that you are seeing there. So I'll start briefly with neuroevolution, and then I move to digital transformation. So in artificial intelligence, we have a good number of methods, and one of them is deep learning. Some people are calling it the Ferrari of machine learning, and you can achieve very good things and amazing results. So these are really a subset of machine learning algorithms, and they are inspired by nature, by hierarchical structures of human perception. And you see a good number of applications when using deep learning. Like in computer vision, for instance, this is the most used area for deep learning, where you are trying, for instance, to try to recognize images. If you have Alexa at home, and you just try to do something with Alexa, you shout, and then the idea is for Alexa to recognize what you are saying. So behind that is deep learning. You might remember in the 90s, there was a breakthrough with Kasparov, world chess champion, and being beaten by Deep Blue, developed by IBM. So we have been using games for a long time to really try to understand these artificial intelligence techniques and so on. And nowadays we are using other very interesting games that are extremely exciting to explore different areas of deep learning. So this is what we are using in our group, this kind of games. And so people tend to think that deep learning is very new because it became very popular just a few years ago, but that's not the case. They have been with us for a good number of years, but we call it neural networks back then, 3 decades ago. And so why is this so popular? Well, there are 3 reasons. One is we have computers now that are way faster compared to the computers we had 1 or 2 decades ago. We also have lots of data, and this is the result of having social media like Facebook, for instance, Twitter, and so on. And so it's very easy to get data nowadays, and lots of data is now labeled, which helps a lot in artificial intelligence. And the other one is that, of course, we have been learning more and more things. And eventually, we are learning so many things that we just don't require too much human expertise to be using these kind of cool things. So I have been talking about deep neural networks, but I haven't described them, what they are, and so on. And the idea is that these are just units, and we call those units neurons. And those neurons are connected with each other. So we get inspiration from the human brain, basically. And then we are using something we call weights. And then these are just numbers. And if we use the proper numbers, we can have a neural network that can behave extremely well. And you can achieve extremely, very, very nice results. And Hinton is one of the people that I started working in the area. At some point, he was probably the only person working with neural networks because they didn't behave in the way that we were expecting to behave for some very simple problems. And nowadays, we have hundreds, if not thousands, of researchers in these deep neural networks. And so we call it deep because we have different layers, and these different layers will extract more and more features. And why is this important? Because the more features you extract, the better the network is going to behave. So here is an example of a deep neural network. There are different flavors. This one, we call it CNN. So you can see that there is one layer here, another layer here, and so on. The input could be an image, for instance. And let's suppose that in this image, we have a number, single digit. And the idea is to know if the image presented to the system is a 0, 1, 2, and so on. So the output is exactly what I'm saying there. We have 10 digits, single unit. So this is an example of neural network. And as I was saying, it achieves impressive results, really impressive results. Nowadays, for instance, there is a very nice competition, and the idea is to classify images. And the accuracy that these systems are achieving are incredible. Some of them are much higher compared to what a human being would be able to do. But still, every now and then, it makes some mistakes. For something that is very easy for us to classify as a fly, the neural network can tell you that maybe that's a dog, which is not the case. So with this, I'll finish the first part of the talk about deep neural network, and I'll focus on the other part that maybe you will be more interested if you are coming from business. Before moving into that part, here's an example of the kind of data that the community tend to use for computer vision problems, for instance. We call this the MNIST dataset, and it's hugely popular. So I just want to conclude this talk by talking about a framework that some people call it digital. And so each of these characters that you are seeing here in digital means something like data, integral, ground, leadership, and so on. So these are guidelines to be applying artificial intelligence methods into businesses. So if we want to adopt then these methods, and importantly, that is diverse and representative. Intelligent is referring to the fact that we still need expertise if we are planning to use these deep neural networks, for instance, or any other form of artificial intelligence. And so the question here is, how can I really acquire this expertise? So I'll discuss that. Be grounded. So when I was reading this paper that I was mentioning before I started the part, there was a very nice discussion about successful businesses and something they call legacy companies. And the difference was that for successful companies, they were ready to test parts of the process and adopting artificial intelligence methods into that process rather than implementing the whole thing and using artificial intelligence. So they were grounded on the research. The other part that that paper was discussing is the integral. So if I am collecting lots of data, first I really need to make sure that the data that I'm collecting will be able to answer something. That will be the aspect of that. And then the other part that I consider very important is the alignment between what we are collecting, the data, and also the technology that we are using. So I focus my attention on the first part on deep learning, but there are really a good number of techniques that you can be using. If we are planning to work alone, then I don't think that you can achieve many things. So some of the things that I mentioned before is that you need expertise, both from the business and from the AI aspect. So the good thing about working together is that we can tailor a solution according to the needs of the company, rather than buying something off the shelf. Agile, we really need to be ready to embrace changes and be flexible. This is something that happens very often, especially when you are using some specialized AI techniques. And this goes hand to hand with leadership. So someone really needs to make decisions in terms of what we should be doing, what we should be collecting, what is the strategy for the business, and so on. So that's everything from my side. Apologies for going over 5 minutes. I will be more than happy to do some collaboration with you guys. I'm also interested in supervising PhD students or co-supervising PhD students. And so with this, I conclude and I open the floor for discussion. Thank you. Can you hear me?
So we can hear you. All right. Edgar, I just have a question, you know, that you kind of covered in it. I'm by no means an expert in any things, but I worked with a company who used, you know, we were looking at process control data in the manufacturing environment about 15 years ago. And one of the key reasons we didn't use neural nets, we investigated them at that stage, but it was kind of seen as that they were unreliable or that you couldn't be sure exactly what they were doing, that was kind of a perceived problem. Can you kind of outline what's happened in the last 15 years that's kind of made them, you know, more, is it just purely down to processing power, or, you know, have the algorithms themselves improved a lot in terms of understanding what exactly the, you know, is going on behind the scenes, or is that still a problem? Because I believe it is still kind of a perceived issue with the black box kind of phenomenon.
Yes, yes. So yes, we have been hearing this very often. We don't want to use them because they are black box and we cannot really understand why they are doing what they are doing. So I suppose that there are a good number of elements why these have been more successful recently. the main reason really is because there are a lot of people working on very cool research, and they are really highlighting the kind of things that we should be considering when having a network. So for instance, we know that for certain kind of problems, we can be using some functions that were under the radar, and people tend to use a function that was very, very well known. People were just following the flock, if you like. And I suppose another aspect is that data has played a fundamental role in these kind of things. By having more data, you can have a system that is probably more reliable, although it's fair to say that you don't need data for all the problems you want to solve. That is a myth. But for many problems, you will need lots of data. And the more data, the more successful the system can be, provided that the data is correct. So if we are trying to classify an image, for instance, the label has to correspond to that image. So that's what I believe is becoming more and more popular, deep learning.
Okay. Thanks.
Thank you.
Edgar, that was a very interesting presentation. Again, sort of leading on from what Paul asked there, you know, AI and machine learning has really evolved in the quantitative big data context. Has there been any sort of progress in using AI in qualitative scenarios?
Yeah, that's a good question. I suppose they have been using in those scenarios, but it may be the case that it might be hard to dig those out because people are working on very specific things. So something that related to this question, something that we have noticed is that people tend to believe that that you can be using these networks just for images. That is a misconception, and a huge misconception. And it will be the same for other algorithms like Monte Carlo tree search. MCTS is very popular, and they were popularized because it was used on the game of Go. And people don't realize that you don't have to use MCTS for games. You will need some conditions to be using that algorithm for other areas. And so now, for instance, you can be using MCTS to generate music, to do some clever selling bets and so on. You can be using MCTS for the design of deep neural networks. So I believe that there is a misconception based on the huge quantity of research done in very niche areas. And that's why it's very easy to miss those areas that you are referring to.
Okay. No, thanks. I appreciate it.
Thank you.
May I have a question? Sorry, I could not find the raise hand.
Yeah, sure.
Edgar, I have a question because you know that recently we are talking about affordable technologies. I was wondering that if this is going to be categorized as affordable technologies for small players, because this is very important. This is very strong tool. But also, has there been any type of research on that?
Yes, great. Yeah, that's a very good question. Sorry. Is it affordable? Yeah, it's I'd say that it depends on the kind of things we want to do. So, for instance, talking about my own experience with my team, it's not affordable to us, given that there are limited resources in academia, and so we need to use some specialized hardware like GPU cards, and that makes life way easier. But on the other hand, now there is a lot of research in terms of using mobile phones and how we can use those intelligently when we are using, for instance, deep learning. So again, I suppose that it depends pretty much on what we want to achieve. Also, it's, for instance, when we want to use some technologies, we can be using, for instance, Google provides a free platform to test some of the models that we are designing with deep learning. Or we can go with something with Amazon, and we can be just pay credits. And so that's a very difficult question to answer, sorry, because I suppose, as I said, it depends pretty much what we want to do and how we are planning to deploy that technology.
Thanks very much, Edgar, because I think this is very important. You know that for some proposals that we are working together, it is very important. It should be some type of affordable technology, AI technology tools, something like this, because we're talking about small players and local players. Mm-hmm. And maybe that's the topic that we need to think of, that how offer the small players these affordable technologies.
Mm-hmm. Yes, absolutely.
And if you have any resources related to that, any references for that, it would be great if you could send me on that. Thank you.
Great, thank you.
Yeah, and also from my side, Edgar, fantastic presentation, and I think it touches on a lot of aspects also from what we research are interested from the Innovation Value Institute about digital transformation and this digital transformation paths, where of course AI technology, digital technologies have a huge impact on it. And I think you mentioned that the link between leadership, strategy, and then AI, the combination of this, and I would call that the configuration of the enterprise around this. This is quite important. And towards the end of the presentation, you mentioned PhD and research opportunities around that. And I think this is a fantastic way also with the coffee talks to think about interdisciplinary research projects. I think because there's a lot of research, of course, on the technology, on the algorithms, on data analytics around this, what you can do with AI, prediction model, deep learning, and all this. But I think particularly now with the Innovation Value Institute and Maynooth University, and particularly when I think about the department, computer science, the business school together around this. So these interdisciplinary connections, I think that's what is kind of really beneficial, also to work with companies together. So I was thinking about what could be interesting, and maybe also if you have some feedback on this, kind of the impact of artificial intelligence to business models. So what is kind of enabling different business models? What is actually enabling different configuration in an enterprise? So basically not just analyzing the data and knowing more, it actually kind of processes, workflows, business models can actually be different, can be quite innovative with AI. And I think some research around this would be really fantastic with really that interdisciplinary aspect, business models and artificial intelligence.
Yes, absolutely, Marcus. So for a good number of years, I was focusing my attention only in the aspect of computer science. I just find it fascinating, you know, to be working on different areas. And it has been more or less until recently that I started working with different people. So at the moment, I am talking with people from psychology, for instance. But also we have an interest in working with business, of course, and neuroscientists. Because at the end of the day, this deep learning is inspired by what happens in the brain. So working and making those collaborations is a natural form to really make progress in the field. So I will be very happy to be working with you guys. So as I said, I started already working with Marcus, Sore, Grace, Paul. So it has been great, I think. Correct me if I'm wrong, Marcus.
No, fantastic. And I think there's a lot of opportunity in it. So yeah.
Edgar, thanks very much for that. As a kind of former OR person, some of those things are coming back to me now. Some of those things like combinatorial optimization that I thought I'd ran away from for the rest of my life. Now it's back. Just to say that in the business school, there's quite a few people who do this type of research from an applied perspective. So for example, looking at things like Twitter data and analyzing sentiment out of it, but probably outsourcing a lot of that stuff to people like IBM and so on who do this analysis for us, so to speak, you know, for free. You know, it's not a cost really, or the cost borne by a research colleague. I was particularly inspired by your kind of digital framework, that nice acronym you had to pull together. I think that works really well, and I can see where it might fit into a lot of things that the school is doing around kind of the use of data, because I think, as Marcus said, you said, and also Marcus brought out as well, one of the challenges of this type of work is to get kind of real data. And while Twitter and all that sort of stuff is useful, and we've some colleagues who've done stuff on image processing, again in marketing, at the end of the day, if you can go in and make put a business case to a company that you can help them to categorize or to work with things, there's quite a lot of things there. So I suppose just to say that, to maybe keep lines of communication open, you haven't with Marcus already, so into the business school in that way, and to find out more about what you do and what we do, and how we could maybe work together on projects, because I suppose the area of artificial intelligence, particularly in my area in marketing, is very publishable. It's currently the first couple of papers defining frameworks are in the top journals now. So it's one of those things that, from a research point of view, is very topical, and collaboration would be welcome, I suppose, really just to open a door more than anything else.
Great. Yeah, absolutely. Thanks a lot, Joe. So yeah, as I said, I am very open to this. Something that helped me, for instance, to kind of open or explore other areas really was because I was mentioning this to Marcus, I think, before. I submitted an ERC proposal for the consolidator call, and in those proposals you really need to have something innovative, like beyond the wildest dreams, and it was then when I realized that I really needed to work with different people and neuroscientists and so on. And so yeah, it will be great. I have seen people from the School of Business working on these kind of things, Twitter and so on. Yeah.
Great, thank you.
Great, thank you.
So just to put in there, you'd be more than welcome to come to one of our coffee and talks if you want at any stage and show us your research. We'd be very interested to hear about that here at IVI. It'd be great.
Great, thank you. Yes.
And that's the main idea between the coffee and talk. So just to kind of inspire a few ideas around the community, making connections between the different disciplines, people, and all this. So I'm glad that works around this, and that IVI can help with that. So, but I think Marco had the
Thank you.
Yeah, Edgar, thank you very much for the interesting presentation, and actually is quite related also. And I think next week I have my presentation, the coffee talk, and I will be talking about the responsible AI for patient empowerment. I'm working in digital health, and I'm trying to understand the use of AI in a responsible way. Because of course, when you deal with the data of patients on the medical field, you must be very careful. And so that, first of all, I would really like to talk to you more to understand your point of view, and maybe we can also collaborate on my project, so we can talk offline on that. The question, just, but I'm also aware of the time, is just because nowadays everything is AI. So I would ask to you, what is not AI? So for example, just the decision tree. Is AI or not? Because I know that is very important, but nowadays, and has been there for many years. So nowadays, is really everything AI?
Yeah, thanks a lot, Marco. So just to briefly answer that question, because I think that we are over time, AI really embraces lots of technologies, like decision trees, for instance, or we have also some kind of a tree decision using evolutionary algorithms and so on. So the area is growing, and so sometimes it's very difficult to classify things. And I would be more than happy to have a chat with you later on.
Absolutely. We will talk about the project. Thank you very much.
Great, thank you.
Thanks, Edgar, for that today, and thanks everyone for attending. Just a quick reminder, we will be having a webinar on FinTech, the future of digital payments, later on this afternoon. And yes, come back next week and join us for Marco's presentation as well.
Okay, great.
Thanks very much, everyone.
Thanks a lot. See you. Bye-bye.